Hello, hello, hello,
Hello,
hello,
boss. Kamusta?
hello.
Hello. Kita ba ako?
Hello.
Hello.
Ayan, ayan. Okay na.
Can you hear me?
Oh, okay. Yes, yes.
Okay. Thank you very much, Close. Close, merong mga 20 na, 20 na, ito, si Mr. Singh. Hindi ko alam kung anong nationality ito.
Ano 20?
Ha?
Ano 20?
20 yung nag-register.
Hindi kaya lang, ano yun? Ano? Ano? Foreigner? Foreigner ba yan? Salamin ako.
Hello, Mr. Ratnesh.
Good evening, sir.
Hello, how are you?
I'm fine.
May I ask, where are you from?
I'm from India.
Oh, from India. Okay. Hindi or Tamil?
Hindi.
Hindi. Okay. How did you learn about even learning?
Sir, I was searching on Facebook.
Oh, searching on Facebook, then you see it.
Yeah, there I found the link.
Okay. Welcome. Welcome. Thank you for joining us tonight. What time is it on your place?
Sir, it's 5 p.m.
Oh, 5 p.m. For us, it's
Oh.
30 p.m.
Okay.
Okay.
Okay. Welcome. Welcome. We'll just wait for a few more minutes, okay?
Yes, sir.
Okay. Thank you. Hey, Klaus, thank you. Thank you sa ginagawa mo ngayon. Maraming salamat. I really appreciate it. Tsaka ang ganda ng bilog na ilaw mo.
Ha?
Ang ganda ng bilog na ilaw mo.
Actually, I was teaching already somehow, no? Because in Philippines, right? English tayo, meron tayong mga foreigner. In Philippines, because of the pandemic, there are some limitations on job training, right?
Yes.
Yeah. So for companies, they have some restrictions. So what do some of the university did is that they have extended the online job training.
Oh,
So
okay.
yeah. So I'm teaching some of the universities like PUP under railway engineering, the first batch.
Oh, okay. How did you come across with PUP?
PUP.
PUP. PUP or PUP?
PUP, Polytechnic.
PUP. So how did you
Yes.
come across with PUP?
From President Ryan.
Ryan.
Ryan Evangelista.
Evangelista, the
Yes. So
ICPEP.
ICPEP
Yeah.
president.
Yeah.
So
I think
he is well connected to
universities.
other deans of the universities in the Philippines.
Yeah. I heard Dr. Ryan, right?
Dr. Ryan.
Yes. I heard Dr. Ryan was one of their panelists for their masters. So if you're taking masters and you're for what do you call this, submitting your thesis, Dr. Ryan is one of the panelists who would evaluate your thesis.
Yeah. He's quite well connected to some of the team. Then I think the next batch I thought is the Colegio de Muntinlupa, and I was shocked. I was shocked
Colegio de
because
Muntinlupa in Manila.
Colegio de Muntinlupa in Kupang.
Is that in Manila?
Yeah, yes.
Ah, okay. So yung tamang Muntinlupa sa Manila.
Yes, yes.
Oh, all right.
Then I was shocked because they have mechanical engineering, and then the batch that I taught is my class is all girls.
Oh, they're
Yes.
engineering.
Mechanical engineering.
And they're all girls.
They're all girls, yeah. It's
Yeah,
very,
I would be shocked too.
yeah, I was shocked. Yeah. But it's
It's a
good
pleasant
experience.
surprise.
It's a good experience also.
All right.
And also
What
came
what,
along.
what teaching subject? What collegiate subjects do you teach?
No, it's not. It's an online job training.
Oh, online job training. So you don't teach specific.
I don't teach specific curriculum subject, but I taught them practical what we
Okay.
are dealing with in the industry. So
you're actually giving them credit units.
yeah, it is part of their subject. Yes.
Oh, okay. That's
Yes.
great.
Okay.
How long have you been doing this?
I think it started last May.
Oh,
Last
this
May.
year.
Yeah, it's just this year. So I am and also of course it's a volunteer it's a volunteer activity. So I just want to maybe some of the engineers or upcoming engineers to be inspired on what they will do in the future. So that's a good one. And also it's just giving back, like paid forward. So I told them that especially those in railway engineering, live stream. Are we being live stream?
Yes, we're going live in.
Oh, okay.
All right.
Live stream.
Okay.
I don't know that you can go live stream in using Zoom.
Oh yeah.
Oh, is it?
Perks.
That's good.
All right. Good evening, guys. Good evening. Welcome to another session of Even Learning. I'm here with Engineer Cross Ariola. He's one of my good friends here in Singapore, and he's going to be the speaker for tonight. So, Engineer Klaus, just like many of you, are also a mechanical engineer, and he's a past president of the PSME 69th chapter Singapore, and a good friend of mine. I'll turn now the time over to Klaus.
Yeah, okay. Hi, good evening, guys. Let me share my slide. Okay, hold on for a second. Can you guys see my slideshow or you're seeing the PowerPoint? Donnie? Hello, Donnie?
We can see your slide, Klaus.
Is it the slideshow or the PowerPoint?
The slideshow.
It's a slideshow. Good. Great. Okay. Can we start now?
Yeah.
Yeah. Okay. Hi, good evening, guys. I am it's good that we have some engineers, bunch of engineers here that wants to learn about the basics of smoke management system. I know most of you are Filipinos, but apparently we have participants here from India and Myanmar. So I will speak in English for this training session. Okay. Okay. Just a little background of myself. I am a Bachelor Science of Mechanical Engineering, graduated last 2004. I am currently involved in a master online program. Then I'm also a professional engineer, back in registered around 2015. I'm also the past president of 69 chapter Singapore of PSME, and currently is now senior engineer of a local design firm here. I'm 13 years in building industry, and I have experience in building beam design under the works of LTA, Land Transportation Authority, and I have 5 experience in BIM and VDC. So, yeah. Today, we will talk about smoke management. So the course outline is discussion of importance of smoke management, short review of fundamentals regarding mechanical ventilation. Of course, smoke management is under mechanical ventilation. Different calculation methods of ventilation rate for each fire scenario, and types of fans should be used, and design points need to remember. Okay, guys, the course that we'll be conducting today or tonight is a mix of NFPA and Singapore standard. I'm practicing Singapore code because I'm working in Singapore. So also this presentation is also some of the Singapore standards, but this Singapore standard is also was also taken or referred to or based on international standards as well. Okay. Yeah. So what is smoke management? Okay, guys, can you mute your Yeah. So what is smoke management? Smoke management, a smoke control that utilizes natural or mechanical systems to maintain a tenable environment in the means of egress from a large volume space, or to control and reduce a migration of smoke between the fire area and the communicating spaces. So it is leading the people to escape. Okay, is managing the smoke. So in case of fire, you will design based on your based on your building shape, based on your fire size, which I will discuss later, and manage the smoke so that the people can escape safely to those communicating spaces or to those protected spaces. So that is a simple explanation of smoke management. Okay, so but what is importance? What are the importance of smoke management? Smoke management, of course, is life safety. According to NFPA 92, the containment of smoke. Okay, I repeat, the containment of smoke to the zone of the region by establishment and maintenance of pressure differences across smoke boundaries. Why? Why we need to maintain the pressure differences of smoke zone boundaries? Of course, engineers, if you have a if you, if you have a vestibule or safe space, you need them to be positive pressure than the pressure where the fire or smoke is coming from. So it can push the smoke away from the safe zone or the vestibule spaces. The management of smoke within the large volume space and any separated spaces that communicate with a large volume space. Okay. design objective. Okay. Of course, when we design something, engineers, we have an objective. What is your goal? Okay. So here are the following: containing the smoke to the zone of fire origin. Okay. You see the keywords: containing the smoke, containing. Okay. Here, maintaining a tenable environment within exit stairwells for the time necessary to allow, okay, occupants to exit the building. Maintaining a tenable environment within all exit access and smoke refuge area access paths for the time necessary to allow occupants to reach the exit or smoke refuge area. Okay. Then last is maintaining the smoke layer, okay, interface to a predetermined elevation in a large volume spaces. Okay, Engineer Cross, what is this smoke layer? Okay, if I will annotate, can you see my annotation, Donnie?
Yes.
Yes. Okay, so if there's a person trying to escape, okay, then there's a fire here. Okay, trying to explain, this fire will produce a large number of smoke. Okay, then it will suffocate the occupants. So how can you escape and then see this exit? Of course, to see this exit, guys, is you need to maintain the layer. You need to maintain so this guy can run to the exit, right? Just that's then this is the what you call this thing, this distance from the soffit to this imaginary line is called smoke layer. Okay. Okay. But engineer, what are the types of fire? Okay. In a design, you have an objective, but what is your subject? So your subject to so you want to control the smoke, but you want to know what is the source of the smoke. Okay? Each source, this is the types of fire because each type of fire generates a different volume of smoke. So let us see what are the types of fire. Fuel limited fire, a fire that has a heat release rate that is controlled by the material burning. Okay. Steady fire, a fire that has a constant heat release rate. Okay. T squared T2 fire, a fire that has a heat release rate that grows proportionally to the square of time from ignition. So this one is it's like the fire is really proportionally growing. It's it spreads more than the other fires. And steady fire is a fire that has a heat release rate that varies with the respect to time. The other one is ventilation limited fire, a fire where every object in the fire compartment is fully involved in fire and the heat release rate depends on the airflow through the openings of to the fire compartment. Okay, so what is a fire compartment, guys? So fire compartment is a structure, okay, is a structure, if you see the annotation, a fire compartment is a structure that protects the occupant from the fire or from the source of fire, it protects the occupant based on their design. Some fire compartments are 2 hours. Some fire compartment is 1 hour. Okay? It's based on the structure of your fire compartment. Okay, definition of smoke. Okay, so we have, the types of fire based on their sources or based on the fuel. Okay, then now then this fire generates smoke. What is smoke? The airborne solid and liquid particulates and gases evolve when a material undergoes pyrolysis or combustion together with the quantity of air that is entrained or otherwise mixed into the mass. So, uh, I think I when I was practicing already my engineering field in design, I was this is one of the misconceptions is that I thought smoke is only gas. Okay, but now we know that smoke is also solid and liquid or gas depends on the depends on the fuel or the way it has been combusted. If your fuel is not really combusted thoroughly, then if it's a chemical, of course these vapors will mix with your smoke, which is very dangerous when you want to escape from the fire itself, di ba? That is why in Philippines, if you remember one of the accidents in a certain hotel wherein there are a couple of people found in the toilet that is sitting in the corner, then they died from suffocation because this smoke eats the oxygen and then it will make you nauseous at once and then will be disoriented. Then you cannot see already the exit exit passage. So it's very dangerous to if this smoke is already inhaled of an individual, especially if we don't know what is the source of the fire. So we have a design basis. Design basis for smoke management with a given large volume space and as unseparated spaces shall include the determination of the following parameters. The design basis fires used to calculate smoke production. Okay? Example, type, location, quantity of fuel for each design basis, extent of coverage and reliability of automatic suppression, and extent of type ventilation. Why we need this? This is important parameters for us to calculate the exact volume of air that we want to extract because on the exact volume of smoke it will produces based on the based on the source of fire or fuel. They say then also you need to, that's why there is one here. It's type, location, quantity of fuel. These are the things that we need to cater or we need to know before we do the design. Because even the type of let's say that the type of establishment, okay, whether it's a commercial or private, the location of fire, whether it is in a confined space or whether it's in an atrium, okay, height or cross sectional area and plan area of the large volume space to be protected. Okay, height, cross sectional area, plan area of each unseparated space that communicates with the large volume space. Type and location of occupancies within the and communicating with a large volume of space. Barriers is, if any, that separate the communicating space and the large volume space. And what are these examples? These are some, for example, is fire roller shutter, which is separates one volume space to a communicating space. Egress routes from the large volume space and any communicating space, and areas of refuge. So these are the design bases that you need to know before you proceed into the design or the calculation itself. Okay, what are the design approach? Okay, how will you approach smoke containment system? The design approach for smoke containment system shall be one of the combination of the following. Okay, so we have number one, we have stairwell pressurization, we have zone smoke control, we have elevator pressurization, we have vestibule pressurization, and smoke air refuge area pressurization. So these are the different kind of pressurization in a smoke management that we need to know or we need to consider based on your design architectural layout or your fire escape route. So in you need to consider, guys. Also, you can coordinate with your architect the fire escape route. These are the ones who are responsible to design how the people will escape the building. Okay, but we are the ones who will manage the smoke for them to escape. Okay, traditional calculation methods. How can we deal with the how do we design? So one of the methods how do we calculate the volume of air we need to extract is by air change, or we need to input to the space, or how to pressurize is through air change. Okay, so air change is equals to the measure of air volume added or removed from a space divided by the volume of space in 1 hour. Okay, so that is air change. So in air change, for example, in Singapore staircase, we use for air change to pressurize the staircase if it's a normal staircase. But if it's a pressurization staircase, then it's a different story. You need to maintain 50 Pascal, and you assume that there are at the maximum of 3 doors open. So, and then you will design the ventilation requirement so to make this staircase pressurized at 50 Pascal. Okay. So it's not always we use in air change, but in some like for example in lift pressurization, lift usually use 10 air change for lift pressurization, and also for those smoke stop lobby, we use also 10 air change for designing the required air for smoke stop lobby in at 10 air change. Okay, so we have discussed this. What is the design parameter? We have introduced these design parameters a while ago. So we have first is the fire size. Okay, what is fire size? Fire size is knowing how big the fire will be based on the hazards that you have in a certain space. For example, a room full of chemicals, the fire size is different on an office space that is full of papers or computers only, right? So the fire size is different. Or for example, a depot that have a 20 megawatt fire size because of the 6 cars MRT 6 cars MRT in the depot, and you have in depot sometimes you have as much as 150 if they are all parked in the depot, di ba? So others is height of the space, smoke layer height, sprinkler. Then we need also to consider whether is your space sprinklered. If it's sprinklered, then you need to know at what temperature it will burst. Okay? Or if it's not sprinklered, then that's a different story. Okay? Then smoke clearance height. Okay, what's your height? What is the height smoke clearance that you need for the people to escape, right? Then the others are temperature of sprinkler to burst, which I just mentioned. Okay, so height of first indication sample. One of the sample formulas. All this one is taken from NFPA 92. So one of the examples is that height of the first indication of smoke with no smoke exhaust operating. So this is the distance. Z is the distance above the base of the fire and to the first indication of smoke. And then H is the ceiling height of the surface. T is for time. Then Q is the heat release rate from steady fire. So this is the fire size, the Q. And then area is the cross-sectional area. So you need this to calculate the Z over H. Usually is to get the next for the what you call this, the distance above the base, the distance between the base of the smoke to the first indication of smoke. So if you want to calculate the plume of the smoke based on your fire size. Okay, if you want to calculate steady design fires, is delta T is equals to the total fuel of mass consumed and then heat combustion of the fuel over the heat release rate. So if you want to calculate the you want to calculate the heat combustion, then you just have to transpose the figures, which is what is given. Okay, what are the kinds of plumes? Okay, these are the kinds of plumes. We have asystmetric, we have balcony spill, and then we have window plumes. Okay, so this balcony spill is usually seen in a mall or hotels. So if you so it depends. So what you need to be certain is you need to know what is the what in such space. Like for example, you're designing engineered smoke control in only for atrium, then you need to understand what is the geometric architectural layout for this. Is it more onto balcony, or is it more on asystmetric, or is it more on to window plumes? So this is how you study when you come up or when you go for designing the smoke management. Okay, so if you're going for assistant plumes, you will use this formula. So if it's Z1, ZL, or no, ZL is limiting elevation, QC is the convective portion of release rate. This is the Q is your fire size. Then distance above the base of fire to the smoke layer interface. Then you have a mass flow rate in plume at height. So this is what you want to get. Okay, in order for you to design the fan to suck the air to clear your smoke clearance height, this is what you want, what you need, the mass flow rate. Okay, what if it's balcony spill plumes? Then if it's balcony spill plumes, the mass flow rate is equals to 0.36 times the heat release rate times W, the width of the plume as it spills under the balcony, squared, raised to 1/3 times the height above the underside of the balcony to the smoke layer interface. Okay? So, if you have a balcony, let's go to the balcony first. So, okay, here. So if I will annotate, this is the underside of your balcony, okay, to the smoke layer. That's what it means, guys. Okay, if it's a window spill plumes, this one, window spill plumes, So if you see the ZWHW, so 0.68 times the area of ventilation opening, the area of the window, or the area of the opening, and then times the height of ventilation opening, okay, raised to 1/2 and raised to 1/3 times the ZW height above the top of the window. Okay, above the type of the window. You see this window? So this is the ZW, guys. ZW. Plus 1.59 times the area of the window ventilation opening and height of the ventilation opening raised to 1/2. Okay, so these are only few examples of the formula taken from NFPA 92. There are more formulas based on different scenarios of architecture uh, and based on the source of where's the source of fire. There's also a formula which I have not discussed, is that if you're in a really a very small, let's say you have a long corridor, then this one is only maybe 4 meter. That's a different also calculation. Okay, because your fire and this one is very little. The distance is very little, so the smoke spreads a little bit faster. So the things that the calculation here is also different. The requirement of air to clear the smoke clearance height is a lot. Okay, so it depends on your scenario. So you need to take a read of the whole NFPA 92 because there are many case scenario from there. Then you will need to compare it on your geometric layout and your parameters, given parameters on your design. Okay, so type of mechanical fans. What do you usually they what the, you will use a class H uh fire smoke fan, or it is like a bifurcated fan. Because why bifurcated fan? Because the motor is outside. If it's outside, any fire or maybe very hot smoke that's coming or sucking from this fan outside is will not affect the motor or will not burn the cables inside the so the fan will continuously operating. Okay, which is very important. I think that's what happened on one of the accidents in Philippines. I think they didn't use the bifurcated fan. What they I think what they use is air handling unit, which they diverted the air going out. Then they have a bypass duct. Yeah. Okay. What are the smoke management auxiliary devices? Okay. So we have are smoke dampers. Okay. Then we have smoke curtain. Okay, what are these smoke curtain? Is this okay? This smoke curtain, you need to have a very coordination with architect, because you know why? Because you need to plan the escape route. Okay, there are not all the time that your smoke curtain will be half opening, which is what you see in this picture. Some, based on the based on your smoke management, there are some chances that your smoke curtain must be fully dropped down. Then of course it will affect your design costs if you will not manage it well, because if you will buy a very long smoke curtain, then it will be very costly. And mind you guys, smoke curtain is a very difficult to maintain, because once this smoke curtain fall down, or once it drop down, then it drop down very like for example, it's a full drop, which is 4.5 or 5 meters. I think some smoke curtain suppliers or have a difficulty to roll the curtain up. Yeah, that's I think that's one of my experience here when we're doing testing. Once it drops down to a certain height, it's very difficult for the smoke curtains to roll up to its original state. Yeah. And sometimes, okay, but if you're certain that you want to make it permanent, you can use a smoke barrier. So in case of fire, there are no maintenance. This is a maintenance fee. There's a smoke barrier, so it can direct the smoke based on your smoke management plan. This one you don't need a maintenance, guys. Okay, another thing is the smoke sensor. Of course, this is the one who will trigger if there's something, there's a smoke or fire scenario on your premises. Then it will trigger the smoke alarm control panel, which will trigger your engineer smoke control system, okay, or smoke fan system. This is what it looks like. But mind you guys, smoke sensor, you need to carefully design the location of your smoke sensor. If it's too high, it's very difficult to maintain. When it gets dusty, sometimes it makes false alarm. So you need to maintain smoke sensors every 3 months. When it gets dusty, it's very hard to see whether it's a real fire or it's a false alarm. Then it's very it create nuisance to your occupants. And then this smoke control panel, usually this is located in the FCC room or fire command center. Then this one is should be independent to your fire alarm panel. Okay, it should be independent to your fire alarm panel. Okay, but this one is located in a fire command center. Then this indicates which zone. If you can see, this indicates the zone, because if this fan is activated by a certain smoke device, smoke sensor, then this one will run. Then you know already which zone is having a fire scenario. Okay. So we have discussed already basically the major part of a smoke management system or smoke engineering system. Okay, but the thing is that I want to review guys the duct design. Okay, in case that you're not familiar with the duct design, then here's what to consider. We need to, especially when you're designing smoke engineering fan, you need, these are very, very large duct. The volume of air based on the space will create a large duct, which sometimes creates no what you call this, creates trouble in architect's point of view, because how can he manage a very large duct that can be seen by all of the tenants and especially the client? Then what for that he designed the architecture very systematic. If there's a large duct banging on a large space on a corridor, that's very ugly, right? So what are the things that we need to consider? So space availability, okay, routing is important, because this routing might also cross in some spaces that will that will breach the fire compartmentation plan of the architect. So you need to route your dock away from any fire compartmented space. Then another is material, especially for this smoke management. You will use a thick gauge. So usually I use 16 or 18 gauge of duct. This is a very thick, in minimum of 1.2 mm thickness of duct. Okay. Then material sometimes okay, all ducts for engineering smoke control is fire rated. So you need to also have a proper fire rating element there, which is tested, need to be class O material. So to be retardant to fire. Okay. Then of course, noise level. Engineer close. People are people are running for their lives. Why do I need or to cater or to take care of the noise level? Engineers, be mindful. You need to test these systems once in a while. I think, if I'm not mistaken, this is, you need to have a maintenance of twice a year or 3 times a year. 3 times a year. So you need to cater for the noise levels. If it's too noisy, then we need to mitigate it. Air leakage. Okay? You don't want to your smoke ducts to be leaking around or leaking from any duct. Okay? Next is balancing. The next is fire and smoke control. And of course, we need to do also initial investment costs. We need to cater the capital. Then the client need to be aware on how much it will cost for the system. Then the last is the system operating cost. Of course, once in a while, we need to test it. We need to cater how much does it cost when they operate it once in a while. And of course, especially during fire, it depends on the severity of the fire. Then it can be until 2 hours. So they need to know what will be the estimated system operating cost when you run the system. Okay, let's go fundamentals. Of course, when you go for Bernoulli's equations, then v squared is so streamline velocity squared is over 2 plus the integral of absolute pressure over density plus acceleration over times elevation, okay, which is in Newton meter, Bernoulli's equation. Then if we will have to simplify, then the delta P total pressure change between sections 1 and 2 is equals to the total pressure change minus the thermal gravity effect. Okay, in a duct system, okay, so this is usually, okay, this is on a smoke engineering smoke control system, depends on the complexity of your design. Okay, sometimes it can be like this, but sometimes it's just plain straight duct with all your grills or grills with motorized dampers. Okay, but as much as possible for engine smoke control, we need to limit the system pressure loss. Of course, if the more bends, what is system pressure loss? Is the loss of pressure from your fan to the last terminal. Of course, if you have so many bends, then you will lose a lot of pressure, right? So, for example, we have a trunk duct, then we have these branch ducts, we have round duct, and we have terminals, okay? So, in engineer smoke control, you can design rectangle and you can design circle duct. Depends on your architectural layout, which is more advisable. If it's a large space, you can design circle duct. If it's just a normal space, rectangle duct to to save spaces for other services can be considered. Okay, so these are the following duct sizing methods. We have equal friction method, which we have a guide of 0.6 to 0.8 Pascal per meter. Velocity method, which is commonly used for engineered smoke control. Okay, so you normally, because of the large volume of air in engineered smoke control, we normally use 7 to 10 meters per second, but usually it's around 10 meters per second to 12 maximum. Okay, we don't want to have large, very fast velocity, because the fast velocity, then there's a lot of pressure drop, which makes your fan very big. Then let's see, then it will affect also the size of your genset. Be mindful that your genset that these fans are running in emergency mode. So it means it will be supplied from your genset. The power will be getting from the genset of your building. Okay. Then we have a static regain, which is commonly used in industrial ventilation, and constant velocity method, which is common in kitchen and in toilet exhaust duct. Okay, these are guidelines from SITSE. This is the typical noise. This is a guideline not only for engineered smoke, but also for other usage. Okay, then this is the duct sizing chart. So if you have a duct sizing chart, so basically, if you can see the gray area, that is the zone which is favorable, recommended by ASHRAE. So then we come with the pressure drop. So the pressure drop is the total pressure caused by friction, fittings, equipment, and net thermal gravity effect for each section of a duct system is calculated by the following equation. So delta pressure, net pressure, is equals to the pressure loss by the friction from the ducts, from the fitting, from the equipment, and from the stocks. Then if you have quite numerous of fitting, then you will multiply it based on the number of fittings. Okay. So basically, it's the summation of the pressure loss from different fittings or equipments. Friction losses from Darcy and Colebrook equation is the friction losses in terms of total pressure is equals to 1,000 times the friction factor times duct length divided by the hydraulic diameter times the density times the velocity squared divided by 2. But what is hydraulic diameter? The hydraulic diameter is equals to the 4 times the duct area, millimeter squared, over the perimeter of cross-section. Hydraulic diameter is the momentum analysis can relate average wall shear stress to pressure drop per length for fully developed turbulent flow in a passage of arbitrary shape but uniform longitudinal cross-sectional area. Okay? So if you are going for the duct fitting loss, which we usually can be found in SMACNA, okay, SMACNA says that the total pressure loss of the fitting is equals to the coefficient local loss of fitting, which is dimensionless, times the velocity pressure at the section of the fitting, which is in Pascal. Then the velocity pressure is equals to the density, which is the density times the fluid mean velocity, which is meter per second over 2. So this is the sample of SMACNA, which is we have a Y. Oh no, it's a T45 entry branch. So there's a difference, guys. If you're taking a main branch, so it means the air is going here. But if you're taking a T branch, so its air is going here, which is a different, like maybe your unfavorable terminal is over here. Then you will need to take a T branch here. Then it's a different calculation. Okay, so reverse sizing. So, of course, you have a large volume of air coming out, which is the smoke coming out from your system. Then the reverse size can be sized based on this. If you're looking for exhaust, so with the airflow, let's say this one is around 8 meter cube per second. Okay. Then we have, usually we are using around 3 meters per second, 2 meters squared. If you have 8, let's say for example, you have 8 meters per second. Wait, I need to annotate. Then your louver is around 3.3 square meter. But for what you call this, because you have a large volume of air, which is can be until 30 meter cube per second, then you can size it based on Q equals AV. Then taken the velocity of this one, maybe around. So if you want to do the area, Q is equals to, no, sorry. A is equals to Q over V. So Q over V, then the velocity usually is, the velocity is around 5 meters per second. For a large volume of air. When we are talking about engineer smoke control, guys. Okay. Okay, fan system effect. Fan system effect is the system effect of the actual volume of your fan, or the system actual design system curve of your fan. Of course, you need to consider what is the calculated system design volume, and then what is the actual design volume. Okay, so this is how you will, when you're selecting your fan, you need to know what is the system curve, which mostly suppliers will guide you guys. This is an example of system effect. So if you can see, we have a centrifugal fan here, example only, wherein the fan is blowing to here, but the air is usually only at the upper volume. Then it will come such a time that the air will be distributed here. Then it will be equilibrial here. Okay, then it will be flatter here. So this is the system effect. Example of system effect, guys. Okay, so when you do a fan selection, what you normally do, we see is You have an airflow, you have a static pressure, okay, and then it on the catalog you will see a fan curve. So from there you will then this circle is your duty point. Okay. Then normally we don't want to size the fan, which is we don't want this to size your fan or select your fan outside the fan curve. Normally you want to put extra space from here from your fan, then your your duty points around here. That's the best selection. At least you have a space to upgrade or something to expand your impeller. Okay. Engineered smoke control is a large, these are large fans. These large fans produce noise. Okay. Then fan can generate sound octave bands. High airflow or high static pressure loss can generate high noise levels. Noise control can affect the health or activity of a person. This noise is considered a hazard according to OSHAS. Okay, noise criteria. This is from Singapore Standard 553. Okay, these are the noise criteria. Remember, even your fan is running during power, you need to test. Then during this testing, you need to consider how far it will take from the recommended ambient sound level. Then you need to notify the client that this day you will not you will be doing testing for your smoke fans. Then you need to cater for the noise. So here, what is the OSHA's noise exposures? So for 8 hours per day, usually the sound decibel is required is until 90. But if it's a half an hour, if it's more than 110, then it's not safe. For 15 minutes, 115 decibels is more than 115 is already not safe. So what we'll do? Okay, you can also cater for silencers, but for engineered smoke control, okay, for engineered smoke control, we usually use rectangular fans, rectangular silencers. Why? Because this can it's more effective for large volume of air. Okay, silencer selection. Okay, what are the things that you need to do? Determine the noise first, noise criteria of the space, and then select a fan to determine the sound octave levels. Then determine how many decibels need to decrease. Okay, you selected your fan, and then from there, you know how many decibels you need to decrease. Okay. This noise criteria might not be based on under what you call this, under OSHA, under recommended sound level, but you need to notify the client, are you agreeable with, let's say, maybe 50? Are you agreeable with 55? Then you need to have a like an email record that you agreed with 55, then I will design it based on 55, because it is not also recommendable to have 45 or maybe let's say 35 decibels if you're just testing 3 times a year, right? So you need to meet you need to meet halfway with the client. Okay, I have designed in a depot with this large of silencers. So this is a fan from an underground depot, MRT depot, wherein we have large number of duct and big ducts and big silencers and big fans. These fans are around 45 cubic meter per second. So it's a very, very big fan. It's around 2 meters fan, 2 meters in diameter. So we need to points to consider: physical size of the attenuator, the silencer, and of course the pressure drop. Big silencer, big pressure drop. Okay, so this is a sample of the calculation. So if I have here, this is a calculation from a fan supplier, and this is how they calculate the acoustic analysis. So you will input here the outlet of your fan. Okay, then you need to see where is your distance between the terminal. Then what is the area of your grill? Okay, then what is the position of your grill in the room? Then it will calculate the direct sound pressure from your sound power level. Then you need to do also, you need to ask whether you need to input whether it's a dead room or what kind of absorption. There's some choices. Then what is the volume of the room? It will affect, of course, when it's if the volume is small, then the sound doesn't disperse. If the volume is large, then the sound disperse, right? And then here you will, then this is the silencer recommended, and this is the diminishing decibels that it can decrease from your fan sound power level. Okay, then of course, lights and safety ventilation. These are the protected staircase. These are the protective areas that I'm talking about earlier, wherein we have staircase pressurization. This is to pressurize the staircase. Whether it's if it's 4 floors, then it's let's say it's only a 4-inch staircase, but it's more than more if it's 3 floors, then not 24 meters. If it exceeds 24 meters, then you need to have a pressurized staircase. If it's within 24 meters, then it is only a normal staircase, which is a 4-inch. Then if it's a pressurized staircase, then you need to have a 50 Pascal pressure. And then wherein you will assume 3 doors open, and then you will also need to calculate the loss from the door. Then from there, you will have your staircase air volume that you need. Then smoke purging, usually smoke purging is around 9 air change. Okay, car park smoke purging, if it's in a basement or enclosed car park, which is also around 9 air change. Engine smoke extraction, it depends on your which I just discussed earlier. It depends on so many parameters. So it depends on your case. Then natural engine smoke ventilation. This is used by CFD. Okay, this is discussed by CFD. This one, natural engine smoke ventilation, is usually run through simulation. Okay. Okay, purpose of smoke ventilation. This is to improve the visibility on a long distance escape route. Others will be improved tenability during escape. Then also visibility and tenability for the firefighters as well. And then this is to limit also the smoke spread during evacuation and to limit the smoke damage to equipment and furnishings. Because when usually like for example in most of the fire accidents, the smoke also have a remains a stain on the walls, on the paints, or also in the equipment, like your AHU or fan coil. If it's not turned off at once during the fire activation, then this will also then some smoke have odors that will also stain on your ducts, which will also provide nuisance during when it goes to operation again. Yeah, yeah. Okay. So if you have any questions, I can be reached in these numbers and also email. I know that there are some questions around. Some calculations, if you have you want to have a sample of calculation, I can provide you in a separate discussion. Okay? Any questions I can entertain now?
Hello, Klaus.
Yes.
May question sa chat group. Ay, sorry.
Yep. Yeah, sure.
Sabi dito, it says here, I asked what is the ideal distance to conduct traverse test from discharge fan from the elbow. So I think he's asking for the distance from the duct accessory up until to what distance that you will make the traverse to do the measurement.
Ideal distance, usually, well, from my experience, around 5 meters.
5 meters.
Yes.
Kung walang 5 meters,
it can be tested, but the accuracy or the efficiency of the apparatus might not be that efficient. If you're asking.
okay, thank you. Another question, Klaus, if these slides will be provided.
Yeah, sure. No problem.
So for those who have registered,
It will be. I will send them through PDF.
Yeah, Klaus will send it to me, and I will send it to you guys.
Yes.
All right. Any more question? I think the reason why is engineer Klaus says 5 meters, no? Because you want your flow inside your ducting to be laminar flow, to be as possible.
Like that I just showed to you. You need to also consider your system effect.
Yeah. All right. Any more question, guys? If there's no more question, thank you very much for joining us. If you have any other question after this session, you can contact Engineer Klaus directly, or you can contact me. Okay. For those who have registered, you can reply to my email, or for those that are joining us in Facebook today, you can message us at even or comment on our video, and we will get back to you as fast as we can, as early as we can. All right. Thank you very much, Engineer Klaus. Thank you for joining us and for sharing your knowledge with us tonight.
Yeah, I hope guys you have to. I hope guys that with my sharing tonight, we need to also cater for the future building safety of our country. And let's avoid again the accident we're in people was not able to escape during fire scenario.
Okay. Thank you very much, Inter Claus. We'll see. Hopefully, we'll be able to see you again next week for another edition of our event learning. Okay. Thank you, guys. Thank you. See you
Thank
again.
you. God bless.
Bye-bye.